Hello, good day. Uh, we are speaking about introduction to the investigation of operation. Our, our team members are
Félix Carrillo.
and Mario Hernandez. What is the operational research? It is the application of the scientific method by interdisciplinary teams to problems that include the control and management of organized systems in order to find solutions that better serve the purposes of the system as a whole frame in decision-making processes. In this discipline, the following essential characteristics are highlighted: a strong orientation to system theory, the participation of interdisciplinary teams, the application of the scientific method in support of decision making.
Steps to following in applying the scientific method. Problem analysis and purpose. Construction of a model. Deduction of the solution. Test of the model and evaluation of the solution. Execution and control of the solution. In order to implement operational research in practice, the main phases are definition of the problem, model construction, solution of the model, validation of the model, implementation of the solution.
Main linear application of operation research. Most of the practical problems that the IO team face are initially described in a vague way. Therefore, the first activity to be performed is the study of the relevant system and the development of well-defined summary of the problem to be analyzed. Methodology for modeling. Modeling is the complete process of abstraction from the real system to the quantitative model and results in a mathematical model of the real system under study. Formulation. It is the objective component of the modeling and consists of converting the simplified system into a quantitative model that describes it.
A good methodology for construction mathematical models of problem from the simplified problem seems to be the following. Read carefully the testament of the situation in order to understand its main characteristics. Organize in tables all the quantitative information provided by the testament of the problem. Draw an outline of the situation. Identify the elements of the problem. Express the object related to the problem, indicating the unit in which it will be measured. Define the decision variable. Formulate the function of the object and function of the constraint of the mathematical model. Restrictions to build meters of the problem. Main types of restrictions: capacity restrictions, ticket restrictions, market restrictions, compositional constraints, material balance restrictions, internal constraints, restriction for administrative policy.
Formulation of the common linear problems. Linear programming is a class of mathematical programming models destined to the efficient allocation of the limited economic activities. Elements or of the linear programming, the known variables, the objective function, and the constraints. The distinguished feature of linear programming models is that the functions that represent the target and the constraint are linear. Identify the input variables. This is usually depending on the question of the problem. Determine the amount that you want to optimize and express yourself mathematically. The resulting equation is called objective function. Identify all requirements, constraints, or limitations and express themselves algebraically. These equations are called set of restrictions. Express all hidden condition is thus that the statement doesn't mention but are obvious due to the nature of the problem. Concepts of the graphic method and its application. The graphical method of problem solving of linear programming only applies to problems with two decision variables. Regio possible, the set of all points 1, 2, satisfying all the constraints of the mathematical model and forming the feasible region for the problem.
Each equation in constraint A, B, C will give use a Feasible region if evaluated individually as shown below. Graphic interpretation for determination constraint. The feasible region is on the left side due to the restriction. Graphic interpretation for Carpentry restriction. The feasible region is on the left side due to the constraint.
Graphical interpretation for the maximum demand restriction. C. The possible region is on the left side because of the restriction minor that equal. As graph tells us that the possible region is on the right. Each of the graphs will indicate a border where the feasible region will be concentrated. Imagine that each graph is the borderline of a state. The possible region cannot exceed the limit established by the straight lines. Therefore, the graph will be as follows.
What would happen if one of our restrictions were to change? Suppose the following change in our mathematical model. Change d of the restriction and you will get the following graph. It can be observed due to the change that arrows the restriction in our mathematical model. The feasible region is concentrated in the center of the graph. Thanks.
It's all about of investigation operational. Thanks for your attention.